Hello students, now I'm doing class for class 12. The subject is mathematics. So this is the continuation chapter, that is determinant. In the last class also we did the same chapter, that is determinant. Okay, so now we are doing problems from exercise 2b. Each question carries 5 marks. This is page number 177. So let's do question number 37. Right? So if this determinant, this is also the third order determinant, it is given 10C4, 10C5, 11CM, second row 11C6, 11C7, 12CM plus 2, 12C8, 12C9, 13CM plus 4 is equal to 0. Now in this case you have to find out the value of n. So how will you simplify this determinant? Okay? So now here there is in the second column the first element is 10C5 and in the first column the first element is 10C4. If you add these two, that is 10C5 plus 10C4, 10C5 plus 10C4, it is just like your NCR plus NCR minus 1. These two numbers are same, but this is 5 and this is 1 less, that is 4, right? So here also NN same is there, NN same value, but here it is R, but there is 1 less, that is R minus 1. So actually there is a formula for NCR plus NCR minus 1, which is equal to, this is n plus 1 CR, right? So in this case also, what will you get? If you use this formula, what is the value for 10C5 plus 10C4 is equal to, it will be 10 plus 1, that is 10 plus 1, and this is CR, this CR is written there, so it is C5. So which is equal to, how much is it? How much is it? It is 11C5. This is your 11C5. Is that clear now? Now let us prove this result. Let us prove it. So if you know the formula, you can write it directly. Okay? That is NCR plus NCR minus 1 is equal to N plus 1 CR. But in this case, directly you can use the formula NCR plus NCR minus 1 is equal to N plus 1 CR. Okay? So now let us prove this result first. So what is the left hand side here? So here left hand side is NCR plus NCR minus 1. You can do it in the rough vocals, right? Don't show it here. Because if you know this formula directly, you can write it. But if you don't know the formula, let us derive it, right? So what is the left hand side here? NCR plus NCR minus 1, right? So what is NCR formula? It is factorial n divided by factorial r into factorial. It is factorial. This is n minus r. Factorial n divided by factorial r into factorial n minus r, right? Plus what is NCR minus 1? Factorial n divided by factorial r minus 1 into factorial. Difference of these two, that means n minus r minus or minus plus 1, right? Now let us simplify it. You have to simplify it now. Now factorial n, same is there, same term is there. This is factorial r and factorial r minus 1. Which one is greater? Factorial r, you can break this term up to r minus 1. Again, among these two, n minus r and n minus r plus 1, which one is greater? This is n minus r plus 1 is greater. That means you can simplify this term, that is n minus r plus 1 can be simplified as n minus r plus 1 and 1 less, that is factorial n minus r, right? So let us write it here, is equal to factorial n divided by r is more than r minus 1, that means you have to break this term factorial r, that is r factorial r minus 1, right? Next, factorial n minus r, this is factorial n minus r, right? Because n minus, among these two, n minus r and n minus r plus 1, which one is greater? n minus r plus 1. So you have to break this term keeping n minus r as it is, right? So plus factorial n divided by factorial, this is r minus 1, right? So you can break this term n minus r plus 1 up to factorial n minus r. That is, this is n minus r plus 1. Now minus 1 is there. N minus r plus 1 minus 1 is n minus r. So it is factorial n minus r. So it is factorial n minus r. Okay. So what is common here now? Factorial n divided by factorial r minus 1 into factorial n minus r is taken common. So within third bracket, what do we get? 1 upon r plus 1 upon n minus r plus 1, right? So these are the remaining terms within bracket. Now let us simplify it. Is equal to factorial n divided by factorial r minus 1 into factorial n minus r, right? So what's the LCM out here? What's the LCM? It is r into n minus r plus 1 is the LCM, right? So here, now, you have to simplify it. This LCM is divided by r. R gets cancelled. What do we get? N minus r plus 1 into 1 is n minus r plus 1. Then plus sign is there. Again, this LCM is divided by n minus r plus 1. So you can cancel n minus r plus 1. So it remains r only. So r1s are r. Third bracket is closed, right? So here now you can cancel this, r gets cancels. You can cancel it, okay? So is equal to, now this is your n plus 1. So write n plus 1 first, then write down factorial n divided by, now you first write r, then factorial r minus 1, r factorial r minus 1, then write down n minus r plus 1 first, n minus r plus 1, then write down factorial n minus r. So it is simplified, okay? So what is n plus 1 factorial n? So after this n plus 1 comes, isn't it? If you add 1 there, if you add 1 to n, so it is n plus 1. So these are two consecutive terms. So you can write here factorial n plus 1 divided by, here also these two terms are the consecutive two terms, r minus 1, then r comes. So if you combine these two, you will get factorial r. Again, n minus r and n minus r plus 1 are two consecutive terms. That is one after another. So in this case, you can write factorial n minus r plus 1. Okay. So what is this formula actually? You can write it in terms of C form, that is n plus 1 CR. Is that clear to all of you? So n plus 1 CR is the formula for what? NCR plus NCR minus 1, right? NCR plus NCR minus 1 is equal to, what is the formula here? It is n plus 1 CR. The यो formula चाहिँ तिमीहरुले के गर्नुपर्छ, याद गर्नुपर्छ. You should know this formula, right? So in the examination, directly you can write it. Okay? Directly you can write NCR plus NCR minus 1 is equal to n plus 1 CR. Now we will use this formula in this determinant to get the value for what? N, right? So let us do it now. So what is given here? If this determinant is equal to 0, then find the value for n, right? So this is given, let us write down this given. So this is your given, right? So what will you do here is, let us use the properties of determinant. If you write C2 dash is equal to C2 plus C1, it will be 10C5 plus 10C4, 11C7 plus 11C6, 12C9 plus 12C8, so that you can use this formula. Okay? Now, let us write down C2 dash is equal to C2 plus C1. So therefore, now this given determinant, it becomes, first column same, 10C4, 11C6, 12C8. Next, What is new column 2? It is C2 plus C1, right? So it is 10C5 plus 10C4. Next, 11C7 plus 11C6. Next, 12C9 plus 12C8. This is your new second column. What is the third column now? Third column remains same. 11CM, 12CM plus 2, then 13CM plus 4. Determinant sign closed, which is equal to 0. Is it clear now? So now, what will you do? You can simplify 10C5 plus 10C4 using this formula. Again, you can simplify 11C7 plus 11C6 and 12C9 plus 12C8 using this formula, right? So let us do the next step now. So what will be the next step now? Or first column remains same, 10C4, 11C6, 12C8, right? Now, what will be the value for 10C5 plus 10C4 using this formula? If you have NCR plus NCR minus 1 is equal to N plus 1 CR. If you have NCR plus NCR minus 1, then we can write N plus 1 CR. Similarly here, instead of N there is 10 and instead of R there is 5. 5. Okay, this is your 5 minus 1. So what is the formula for this one? 10 plus 1, that is 10 plus 1 CR, R is there, R means here it is 5. Is that clear? Now next, 11CM. Similarly, what is 11C7 plus 11C6? You can use this formula. Like N plus 1 is there. So N plus 1 means here 11 plus 1. 11 plus 1. See, what is the value for R here? It is 7. Compare these two. Here N is equal to 11 and R is equal to, this is 7. Right? And this 11 is N and this 6 is 7 minus 1. Similarly, what is the value for 12C9 plus 12C8 using this formula? Here the value for N is 12. What is the value for R? It is 9 plus 12C, 9 minus 1. What is the formula? N plus 1. N plus 1 means 12 plus 1. It is 12 plus 1. C. What is the value for R here? It is 9. Is that clear? So next, 12C M plus 2 and then 13C M plus 4, which is equal to 0, right? So we have used this formula. Is that clear? So next, so or now this is your 10C4, 11C6, 12C8, next 11C5, this is 12C7, this is 13C9. Now 11CM, 12CM plus 2 and this is 13CM plus 4. This should be equal to 0, right? Now what is asked in the question? You have to get the value for M so that the value of this determinant is equal to 0. So you know that problem number 3, if the two rows or two columns of a given determinant are identical, then the value of the determinant is always 0. Suppose, now in the second column, these are the elements. In the third column, these are the elements. If we put any M is equal to 5, suppose you write M is equal to 5 here, 11C5, 11C5. If you write M is equal to 5, 12C7, 12C7. M is equal to 5, 13C9. This is also 13C9. If you substitute M is equal to 5, then these two columns will be identical. That is, the value of this determinant is 0. So this equation is satisfied when M is equal to 5. If you put M is equal to 5, these two columns are identical and the value of the determinant is 0. That is, This equation is satisfied when m is equal to 5. So what is the value for m? M is equal to 5. Okay. So this type of question you may get in the objective type of question, multiple choice question, right? So let us write down, if m is equal to 5, then second and third columns, are identical. If m is equal to 5, then second and third columns are identical. Therefore, the value of the determinant is equal to 0. Therefore, the value of the determinant is equal to 0. Okay. So now what is the value for m here? What is the answer? So m is equal to 5 is the answer. So is it understood? So this is very, very important question. So you have to understand it. Okay, I think I've understood it. So you can copy it. We'll do the next question, right? So now we will do question number 38. So what is given here? If L, M and N are real numbers, here L, M and N are all defined numbers, such that it is given L square plus M square plus N square is equal to 0. You have to prove that this third order determinant is equal to 1. That is, what is the first row here? 1 plus L square is the first element, Lm second element, Ln is the third element in the first row. Lm first element, 1 plus M square second element, Mn third element in the second row. Ln first element, Mn second element, 1 plus N square third element in the third row. Right? You have to prove this is equal to 1. So let us prove it. So this is the solution. Let us write down D is equal to this left hand side. Okay, write it. Let D is equal to this third order determinant. Okay. So how can you simplify this determinant now? You should have L square, M square, N square, isn't it? Since this is L square, you have to make this L and L as L square in the first row, or you may do it in the first column also. This is LL. You can make it L square, L square. You may make L square in the first row, or you may make L square in the first column. Similarly, in the second column there is M square, make it M square. In the third row, make it N square, because there is N square, because you should get L square plus M square plus N square. That means you can simplify either in terms of rows or in terms of columns, right? So let us multiply the first row by L, okay? And you should write before determinant sign 1 upon L, because you have to cancel that L. We are multiplying ourselves the first row by L, but that should be cancelled. So what will you write in front of determinant? 1 by L. Similarly, the second row should be multiplied by M, but that should be cancelled. So write 1 by M before determinant, okay? So this third row will be multiplied by N. So you have to cancel it. Again, you should write 1 by N before determinant sign. Okay. So therefore now this determinant now becomes D is equal to 1 upon LMN. It is 1 upon LMN. Now you have to multiply. Now you have to multiply the first row by L. You have to multiply each and every element of the first row by L. So what do we get? L within bracket 1 plus L square. Next L into Lm, L square N. What is L into Ln? That is L square N. This is your L square N. Okay, so this is the first row. Now second row can be multiplied by M. Already we have written here 1 by M. So it is multiplied by M. Lm square lm square. It is also multiplied by m into 1 plus m square. This is also multiplied by m. This is m square n. Is that clear? Now we have already written 1 by m outside determinant. Okay. Now third row is multiplied by n now. So it is ln square. This is ln square. Next mn square. This is mn square. Next n into 1 plus n square. n into 1 plus n square. The third row पनि हामीले सबै एलिमेन्टलाई हामी आफै n ले मल्टिप्लाई गर्दैछौँ. त यसलाई क्यान्सल गर्नुलाई नै डिटरमिनेन्टको बाहिरपट्टि हामीले के लेख्यौ? आउटसाइड डिटरमिनेन्ट we wrote 1 upon n. Is that clear to all of you? So now what will you do in the next step? Now again, from the first column you have to take L common. From the second column, M common. And from the third column, N common. Okay? So therefore D is equal to LMN. Common divided by LMN. Okay? L, M and N are respectively taken common from the first row, second row and the third row. Right? So, what will be the new first row now? Oh, sorry, first column. What will be the new first column? From the first column, L is taken common. So, it is 1 plus L square. It is M square. This is N square, right? So, this is your new first column. What is the new second column? Here m is taken common from the second column. N square 1 plus m square. This is n square. Okay? So m is taken common from the second column. Now from the third column, what is taken common out there? N is taken common out there. That is n is taken common here. So what do we get? This is L square. This is m square. This is 1 plus n square. Is that clear now? So here you can cancel this element. Cancel them. So element and element, they are divided. That is one time, isn't it? So now what will you do in the next step? Now, if you do R1 plus R2 plus R3, this will be 1 plus L square plus M square plus N square in the first row. That is the first element of the first row. Again, if all these terms are added, which are in the second column, you will get 1 plus L square plus M square plus N square. Again, if all the terms on the third column are added, what will you get? 1 plus L square plus M square plus N square. In the this is the third element of the first row, right? So we are getting the same element in the first row, so that you can take it outside. Okay, so here we are using the property R1 dash is equal to R1 plus R2 plus R3. यदि हामीले यसमा R1 dash is equal to R1 plus R2 plus R3 गरेर के हुन्छ? यो सबै add हुन्छ हैन? That is 1 plus L square plus M square plus N square is here. This is also 1 plus L square plus M square plus N square is out here. This is also 1 plus L square plus M square plus N square is here. That means same elements are there in the first row, so that we can take common. Okay? So therefore D is equal to, what is the first element of the new first row? It is 1 plus L square plus M square plus N square. Similarly, what will be the second element of the new first row? Again, it is 1 plus L square plus M square plus N square. 1 plus L square plus M square plus N square. Similarly, what will be the third element of the first? What will be the third element of the first row now? It is again, same expression is there, isn't it? So it is 1 plus L square plus M square plus N square. Right? So this is your new first row. Now second row and third row remain same. That is M square, 1 plus M square, and this is also M square. Next, N square, n square, and that one is 1 plus n square. That is second row and third row remain same, right? Is that clear? So now, what will you do in the next step? You can take common here. That is d is equal to 1 plus n square plus n square plus n square is taken common. Now what will be the first row? What is the first row? 1, 1, 1. 1, 1, 1. What is the second row? N square. 1 plus n square. This is also n square, right? What is the third row? It is n square, and this is 1 plus n square. So this is the determinant. Is it clear? So now, there are 3 ones in the first row. You can make any 2 of these ones 0. So अब हाम्रो यहाँ फर्स्ट रोमा 1 1 1 आएको छ, कुनै दुईटा 1 लाई हामीले के बनाउन सक्छौं? 0 बनाउन सक्छौं using the properties of determinant. So how can you use the properties of determinant now? You can do C2 dash is equal to C2 minus C1, C3 dash is equal to C3 minus C2, or C3 minus C1. Which one is easier? That is C3 minus C1. Okay? अब हामी के गर्छौं? यो र यो 1 लाई हामी 0 बनाउँछौं. कसरी? C2 minus C1 गरेर. C2 dash is equal to C2 minus C1, C3 dash is equal to C3 minus C1. Right? So let's use this property now. So now write down the property, that is C2 dash is equal to C2 minus C1, and C3 dash is equal to what? C3 dash is equal to C3 minus C1. So let's use these properties to make any 2 of these ones 0. हामी यो property use गर्छौं. यो property use गरेर चाहिँ कुनै दुईटा 1 लाई हामी के बनाउँछौं? 0 बनाउँछौं. ठीक छ? So therefore d is equal to, within bracket, 1 plus l square plus n square plus n square, right? First column remains same, right? 1 n square, n square. This first column remains same. Now column 2 is changing. How does it change? C2 minus C1. Okay? This 1 minus 1 is 0. 1 plus n square minus n square is only 1. N square minus n square is always 0. Is that clear? And the next one is, again 1 minus 1 is, this is 0. N square minus n square, this is also 0. 1 plus n square minus n square, that 1 plus n square minus n square gets cancelled, so you get 1 only. So this is the simplified determinant. Is that clear? So now what will you do? Now there are 2 zeros in the first row. That means with respect to the first row you can expand the determinant. Okay? So let us expand the determinant with respect to the first row. So therefore d is equal to 1 plus l square plus n square plus n square into. Now let us expand it with respect to the first row. So what is the method for expanding it with respect to the first row? You have to take 1 0 0. You have to consider the sign also. Plus minus plus. I told you that one, isn't it? Plus minus plus. Let us take plus 1. Plus 1 within bracket. Now you have to forget about the row and the column through the element 1. That means first row and first column are deleted, right? Your first column र first column is XII को लागि बिर्सिनु. के रह्यो? 1 0 0 1. That means this is the second order determinant. You know how to expand it. So you have to cross multiply 1 by 1, 1 1 is 1, minus 0 0 is 0, bracket closed. Right? Is that clear? So what is d is equal to now? Therefore d is equal to 1 plus l square plus n square plus n square. Into 1 is always 1 plus l square plus n square plus n square. But in this case, we did not write this minus 0. because minus 0 into any number is always 0, you don't have to write it. Again, plus 0 is there. Again, 0 into any number is always 0. That's why these zeros are not written in this case. Okay, this is the expansion, right? So, what is the final term here? That is d is equal to 1 plus l square plus m square plus n square, right? But in the question, it was given that the condition was given there, l square plus m square plus n square is equal to what? 0. You can put the value of l square plus m square plus n square here. That is d is equal to 1 plus 0. That means d is equal to 1. So it is proved. Is that clear to all of you? So we have got the answer. That is d is equal to 1, which is equal to right hand side. Okay. So you can copy it. Now we'll do the next problem now. Now we will do question number 42. If f of alpha, that means function of alpha, function of x means any expression in x is known as a function of x. That is, any expression in terms of alpha is known as the function of alpha. This f of alpha means function of alpha. It is expressed as a determinant. So what is that third order determinant? What is the first row here? 1 alpha alpha square, this is the first row. What is the second row? Alpha alpha square 1 is the second row. What is the third row? Alpha square 1 alpha. So first of all, you have to simplify this determinant using properties, and then you have to put alpha is equal to cube root of 3, so that this is known as cube root of 3, so that you can get the value for function of or f of cube root of 3. Clear? So now this is the given part. This given part is written out here. Now you should simplify this determinant, but directly you cannot expand it. You have to use the properties of determinant, right? So which property is used to make it more easier, right? So what happens is that, let's do R1 plus R2 plus R3. That is, row 1 is changing. If you do R1 plus R2 plus R3, it becomes 1 plus alpha square. This is also 1 plus alpha square. This is also 1 plus alpha square, and so on, right? Now, you can do C1 dash is equal to C1 plus C2 plus C3 also. This plus that. 1 plus alpha, 1 plus alpha square. This is also 1 plus alpha square. This is also 1 plus alpha square. Is that clear? So now, let's use the properties in terms of columns. That is, C1 dash is equal to C1 plus C2 plus C3. So let us use this property now. Now therefore, f of alpha is equal to C1 dash means column 1 is changing, right? So how does it change? C1 plus C2 plus C3, right? So 1 plus alpha square. Next, again it is alpha plus alpha square plus 1. There is also 1 plus alpha square. What is the third one? Third element of the third row. This is also alpha square plus 1 plus alpha. That means 1 plus alpha square, right? And this second column and the third column remain same. Alpha square 1. Next, alpha square 1 alpha. I think you have understood it. Okay. Now what will you do in the next step? You can take common here. So what is common out here? So therefore f of alpha is equal to within bracket 1 plus alpha square. So this is taken common, right? So what is the first column? 1 1 1. Next, second column remains same. Third column also remains same. Alpha square 1, and this is alpha. Is that clear? Now what will you do in the next step? In the next step, what will you do now? So in the next step, you can make any two of these ones 0 because there are 3 ones in the first column, right? So how can you use the property here? R1 dash is equal to R1 minus R2 and R2 dash is equal to R2 minus R3. Okay? Now you know that in a third order determinant, at a time, maximum 2 properties can be used, right? So in this case also we are using 2 properties at a time so that we can make 2 ones 0, right? So let's use this property now. So therefore f of alpha, that is function of alpha, is equal to 1 plus alpha square, right? So what is R1 dash is equal to R1 minus R2. So how does row 1 change? This is R1 minus R2, that is 1 minus 1, 0. Alpha minus alpha square, then comes alpha square minus 1, right? Next, also row 2 is changing, new row 2. How does it change? R2 minus R3, 1 minus 1 is 0. Next one is alpha square minus 1. Next one is 1 minus alpha. And what is the third row? It is 1, 1 alpha. Is that clear? So now let's simplify it. So now, in the first column, there are 2 elements as 0. Now you can expand it, but before that, here you can take common here, right? There is alpha minus alpha square, here alpha is taken common. This is alpha square minus 1, that is a square minus b square, a plus b into a minus b. Here also alpha square minus 1 is there. You can use the formula of a square minus b square like that. Okay? So let us simplify it by taking common here. Alpha minus alpha square, here alpha is taken common. This is a square minus b square, a plus b into a minus b. There is also alpha square minus 1, that is a square minus b square, which is a plus b into a minus b, right? So therefore f of alpha is equal to you have to write down this common term, that is 1 plus alpha square, right? What is the first column? It is 0, 0, 1. First column 0, 0, 1, right? Here alpha is taken common, so within bracket 1 minus alpha, right? Here from alpha minus alpha square, alpha is taken common, so within bracket we have 1 minus alpha, right? So what is alpha square minus 1? It is a square minus b square, a plus b into a minus b, that is alpha plus 1 into alpha minus 1, then write down 1. So this is 1, right? Similarly, what is alpha square minus 1? Again, same formula, a square minus b square, that is alpha plus 1 into alpha minus 1, right? Then 1 minus alpha remains same, then alpha. So now, there is 1 minus alpha is here. But there is alpha minus 1, this is alpha minus 1, you have to make it 1 minus alpha by taking minus common. Here also you can make 1 minus alpha by taking minus common, so that we can take 1 minus alpha as common from the first row as well as from the second row. But first of all, make this alpha minus 1, 1 minus alpha by taking minus common, right? So therefore, f of alpha is equal to 1 plus alpha square, right? First column remains same, 0, 0, 1. This is your second column, that is alpha into 1 minus alpha. Here minus is taken common, minus within bracket alpha plus 1 into this becomes 1 minus alpha, isn't it? From alpha minus 1, minus is taken common, so minus within bracket it is 1 minus alpha, right? And this is 1. Now third column, from the first element also you take minus common, so it is minus alpha plus 1 into 1 minus alpha, right? So this is 1 minus alpha and this is alpha. Is that clear now? So now what will you do in the next step? From the first row, 1 minus alpha is taken common. And from the second row also 1 minus alpha is taken common, right? So therefore, f of alpha is equal to 1 plus alpha square, right? So from the first row, 1 minus alpha is taken common. Again from the second row, you have to take 1 minus alpha as common. So what is 1 minus alpha into 1 minus alpha? This is whole square. You can write it within whole square, right? So now, what is the first row now? 0 alpha minus alpha plus 1. Is that clear? Next, from the second row also 1 minus alpha is taken common. So it is 0 minus within bracket alpha plus 1, and that is 1, then 1 alpha. Is that clear to all of you? So now, you can expand this determinant with respect to the first column because there are 2 zeros in the first column, right? So let us expand it. So now what is the method for expanding it? So f of alpha is equal to, what are the first factors here? It is 1 plus alpha square, then 1 minus alpha whole square, 1 minus alpha whole square. Now expand it, okay? So let us expand it with respect to the first column because there are 2 zeros in the first column, right? Let us expand it. What is the method? Plus minus plus. Plus 0. Will you write plus 0? No, because 0 into any number is always 0. Minus 0 also you don't have to write it because 0 into any number is always 0. But you should write 1. So into 1. Right? So into 1. So within second bracket. Now if you consider this 1, delete the row and the column through the element. That means you have to forget about the third row and the first column. तिमीले एकछिनको लागि यो थर्ड रो र फर्स्ट कलम चाहिँ बिर्सिने भनेपछि के रह्यो अल्फा माइनस विथ द ब्रैकेट अल्फा प्लस 1 minus within bracket alpha plus 1 and 1. Okay, so now this is the second order determinant. You have to expand it, but you have to cross multiply first alpha by 1. So alpha into 1 is alpha, right? Then minus sign will be there, but again you have to cross multiply minus alpha plus 1 by minus alpha plus 1, right? So minus into minus plus, already minus was there, so minus into plus is minus. So what is alpha plus 1 into alpha plus 1? Alpha plus 1 whole square. So it is alpha plus 1 whole square, second bracket closed, then third bracket is also closed, right? So now let us simplify it now. You can copy it. So now therefore f of alpha is equal to 1 plus alpha square 1 minus alpha whole square, right? So let us simplify it now. Now this is alpha minus, what is alpha plus 1 whole square? This is your a plus b whole square, a square plus 2ab plus b whole square, but here it will be alpha square plus 2 alpha plus 1, but there is minus sign is there. You have to multiply by minus sign, that is sign changes. So minus alpha square minus 2 alpha minus 1. So this is the simplified expression. Because you know that alpha plus 1 whole square, if you expand it, you will get alpha square plus 2 alpha plus 1. So multiplied by minus sign, minus alpha square minus 2 alpha minus 1. Is that clear? So let us simplify it. Therefore, f of alpha is equal to 1 plus alpha square 1 minus alpha whole square, right? And here it is, you let us write minus 1 first, then what is minus 2 alpha plus alpha minus alpha, then write down minus alpha square, right? So therefore f of alpha is equal to, here minus is taken common, write it outside all these factors, 1 plus alpha square 1 minus alpha whole square, then what do we write? it is 1 plus alpha square, because here minus is taken common from that last factor, right? So now next, simplify it. Therefore, f of alpha is equal to, now it is minus, let us write first 1 minus alpha whole square, then you should write 1 plus alpha square into 1 plus alpha square, same expression, multiply them. If you multiply them, powers will be added, 1 plus alpha square, 1 plus 1 is whole square. So both are square term. You can write it within whole square, like if there is a square, b square, you can write it within whole square, that is ab whole square, isn't it? So similarly here also you can write, therefore f of alpha is equal to minus within second bracket 1 minus alpha into 1 plus alpha square, second bracket closed, whole square. Okay? So now you are in the higher classes, you should know this formula. This is from class 8 or 9. Okay? What is the formula? A minus b into a square plus ab plus b square. That is a cube minus b cube. So here it is, f of alpha is equal to minus within bracket. What is a cube here? 1 whole cube. What is 1 whole cube? 1. Then comes minus. What is b whole cube? B is alpha here. What is whole cube? This is alpha cube whole square. Is that clear to all of you? So this is the simplified form of the determinant. Okay? Now you have to get the value for f of cube root of 3. So now write down, putting alpha is equal to, what will you write? Alpha is equal to cube root of 3. Putting alpha is equal to cube root of 3. Okay? So let us write it here. Therefore, f of cube root of 3 is equal to minus within second bracket 1 minus, what is the value for alpha in this case? It is cube root of 3. It is cube root of 3 whole to the power 3 second bracket closed whole square. Is that clear? So next, let us simplify it. Within second bracket 1 minus, what is cube root of 3 whole cube? Actually, cube root of 3 means, what is cube root of 3? It actually means 3 to the power 1/3. Whole to the power what? Cube. Second bracket closed, whole square. You should say cube root of 3, sir. You cube root of 3 भनेको 3 to the power 1/3 हो, याद गर्नु. So if you have nth root of x, what can you write? It is x to the power 1/n. Similarly, what is cube root of 3? It is 3 to the power 1/3. Is that clear? So here you can cancel. This 3 gets cancels. Minus sign. You have to write down that minus sign, which is equal to minus within second bracket 1 minus, this is only 3. This is your whole square, right? So which is equal to minus within bracket minus 2 whole square, which is equal to minus sign, you have to write it. But what is minus 2 whole square? Minus whole square, minus is multiplied twice, so minus whole square is always plus, because minus into minus is plus. And what is 2 square? It is 4. So this is the final answer. So what is the final answer in this case? It is minus 4. So if f of alpha is equal to this determinant, then what is the value for f of cube root of 3? It is minus 4. So that is the final answer. So is it clear to all of you? So we can copy it. We'll do the next question now. Now we will do question number 43. So without expanding, and this problem is from page number 177. That is from the same exercise. That is exercise Exercise 2B, each question carries 5 marks, but you will get this type of question in 4 mark section, right? So this is very, very important. This question is very, very important, right? So without expansion, you have to prove this LHS is equal to 0. So this is the third order determinant. What is the first row? First element b square c square, second element bc, third element b plus c. What is the second row? First element c square a square, second element ca, third element c plus a. What is the third row? What is the first element? A square b square, second element ab. What is the third element? A plus b, right? So let us copy this left hand side. D is equal to this left hand side. Let us copy it. So now what will you do? But you cannot expand it to prove this determinant is equal to 0. Okay. Now in this case, what will you do here is, in the first row A is missing, right? In the first row, what is missing? A is missing. So you should multiply it by A. In the second row, B is missing, multiply them by B. In the third row, C is missing, multiply them by C. But we are multiplying ourselves. You have to cancel that ABC, which are multiplied in the first row, second row and the third row. And outside determinant, what will you write? In order to cancel that ABC, 1 upon ABC. Understood? So therefore, D is equal to, now D is equal to 1 upon ABC, right? Now what will be the first row? Multiply all the elements by A B square, C square, ABC, right? A, B square, C square, then write down ABC, then A into B plus C. A into what? B plus C. Is it clear to all of you? Next one, again multiply it by B. We have already written there 1 upon B outside determinant. So multiply this second row by B now. So what do we get? BC square A square, isn't it? BC square A square. Now this is AC into B, ABC. Now this is B into C plus A. This is B into C plus A, right? Is that clear? Now next, 1 upon C is already written outside. 1 upon C is already written outside determinant. So you have to multiply the third row by C. That is, each and every element of this third row is multiplied by C. So what do we get? A square, B square, C. Next, this is your ABC. This is your, again, ABC. And it is multiplied by C. That is the last element of the third row. That means C into, this is your A plus B. So did you understand this one? Okay. So now what will you do now? There is common now. In the first column, what is common? In the first column, what is common? Throughout the term, ABC. And from the second column also, what is common? ABC. That means ABC whole square. From the first column, ABC is common. From the second column, ABC is common. Take them outside determinant, so it becomes ABC whole square. So therefore, D is equal to, this is your ABC whole square divided by ABC, right? So what is the first column now? What is the new first column? ABC is taken common, so it is BC. From here also, BC square, A square, ABC is taken common, so it is CA. From A square, B square, C square, ABC is taken common, so it is only AB. Clear? And from third column also, ABC is taken common, so it will be 1, 1, 1, right? Now multiply here, A multiply on B plus C line. What is it? AB plus AC, BC plus AB, right? It is BC plus AB, then CA plus BC. It is CA plus BC. A into B plus C, AB plus AC, B into C plus A, BC plus AB, right? And C into A plus B, there is CA plus BC. Okay? Now again, what will you do in the next step? Without expansion, you have to prove this determinant is equal to 0. That means you have to make either 2 rows or 2 columns identical to make that determinant 0 without expansion, right? So now, C3 dash is equal to C3 plus C1. What is there? AB plus AC plus BC. this also, this plus this, AB plus BC plus CA, this plus this, AB plus BC plus CA. You are getting the same elements in the third column, and you can take that common outside. Okay, so what is the property that you can use here? C3 dash is equal to C3 plus C1. That means, how does column 3 change? That is C3 plus C1, right? So let us write down here, next step. So D is equal to, you can cancel here, ABC and square gets cancels. So it remains ABC, okay? First column remains same, BC, CA, AB. What is the second column? It is 1, 1, 1. What is the new third column? How does it change? It is C3 plus C1. That is AB plus AC plus BC. AB plus AC plus BC, right? Next one, C3 plus C1. Again it is AB plus BC plus CA, right? Again C3 plus C1. That is the third element of the third column. So what do we get? AB plus BC plus CA. That is determinant sign is closed. So is it clear to all of you? So now what will you do in the next step? In the next step, what will you do? You can take common here. What is that common? This AB plus BC plus CA is common out here in the third column. You can take it outside. Okay. So let us take it outside now. So let us take that common AB plus BC plus CA outside determinant. Okay. So therefore D is equal to ABC. So within bracket, what is common here? This is common, right? AB plus BC plus CA is taken common. Now first column remains same. What is the first column? What is the first column here? BC, CA, AB. This is BC, CA, AB, right? Second column also remains same. 1, 1, 1. Now what is the new third column? From the third column we have taken AB plus BC plus CA as common. So it will be 1, 1, 1. Now in this case, two columns are identical. That means what is the value of the determinant? 0, right? So therefore D is equal to ABC within bracket AB plus BC plus CA into 0. What is the reason behind it? Since two columns are identical. You're right. Since two columns are identical. So what is the value of the determinant? It is 0. So therefore D is equal to 0 into any number is always 0. Proved. Okay. So without expansion we proved this determinant is equal to 0. Is it clear to all of you? So now we'll do the next problem, right? Now we will do the next question, that is question number 44. So this question is from HS 2017. तो यो क्वेश्चन चाहिँ 2017 मा पनि आको ठीक छ त यहाँ के भन्दैछ यो सो दैट दिस थर्ड order determinant is always divisible by 100. That means you have to simplify this determinant first, okay, and one of the factors should be 100 out there. Okay, so let us simplify it first. So this is the given determinant. Okay, you have to prove that this given determinant is divisible by 100. So what is D is equal to now? What is the first row here? A square plus 10 AB AC. Second row AB B square plus 10 BC. So CA BC, and this is C square plus 10. Right? So now, since there is A square, make it A square by multiplying it by A. There is also B square, make it B square. This also make it B square by multiplying it by B. There is C square, make it C square by multiplying the whole element of the third row by C. Okay. But we are multiplying ourselves by A, B and C for the first row, second row and third row respectively. but you have to cancel them. So outside determinant, what will you write? 1 upon ABC. Is that clear? So write down. So therefore D is equal, let us write here 1 upon ABC. Now first row is multiplied by A. So you can do it in column wise also. त तिमीले यसमा column wise मा गर्दा पनि हुन्छ है यो. त हामी चाहिँ केमा गर्दैछौं? Row wise गर्दैछौं. So A into A square plus 10, right? Then it is A square B and this is A square C. That is first row is multiplied by A and you should cancel it. So we have written outside determinant 1 upon A. Now multiply throughout the element of the second row by B. So it is AB square B into B square plus 10 and this is B square C. So we have multiplied all the terms of the second row by B. To cancel it, we have written 1 by B outside determinant. Again, you should multiply each and every term of the third row by C. What do we get? C square A, right? This is your C square A next. BC square next. C into C square plus 10. Is that clear? So we have multiplied all the terms of the third row by C, and in order to cancel this C, we have written 1 by C outside determinant. Is it clear to all of you? So now, what will you do in the next step now? So in the next step, you can take common from the first column, second column and third column. From the first column, what is common? A, second column B, third column C. Let us take it outside. Determinant, okay? D is equal to ABC divided by ABC. What is the first column now? It is A square plus 10. Then B square. Then C square, right? What is the second column? From the second column, B is taken common. So what are the remaining terms here in the second column? It is A square, then B square plus 10, B square plus 10, and then C square. And from the third column, what is taken common here? C. That is, it is A square, then comes B square, then comes C square plus 10. Is that clear to all of you? So here ABC gets cancelled. You can cancel them. So how can you simplify this determinant again? So in this case, if you write R1 dash is equal to R1 plus R2 plus R3, that is you get here 10 plus A square plus B square plus C square. Here also 10 plus A square plus B square plus C square. Here also 10 plus A square plus B square plus C square. That means we are getting the same elements 10 plus A square plus B square plus C square in the first row, so that you can take that common outside determinant. Okay, so let's do here R1 dash is equal to R1 plus R2 plus R3, right? R1 dash is equal to R1 plus R2 plus R3. So therefore D is equal to, what is the new first row now? 10 plus A square plus B square plus C square. 10 plus A square plus B square plus C square. Again, what is the second element? It is also 10 plus A square plus B square plus C square. Again, what is the third element? 10 plus A square plus B square plus C square. So this is the third element of the first row. Okay. Now all the second row remains same. B square plus 10. B square. What is the third one? Third row remains same. C square. This is C square plus 10. Is it clear now? Now you can take common outside. Therefore D is equal to, what is common here? 10 plus A square plus B square plus C square is taken common. So what is the first row now? It is 1, 1, 1. New first row. What is the second row? B square plus 10. Then it is B square. Next, C square. Then it is C square plus 10. Is that clear now? What will you do in the next step now? In the next step, अब हामी के गर्छौं? There are 3 ones in the first row. You can make any 2 of these ones 0 by using the property. That is, how will you use the property? C2 dash is equal to C2 minus C1 and C3 dash is equal to C3 minus C2 or C3 minus C2 or C3 minus C1. Which one is easier? C3 minus C1 is easier, right? So C2 dash is equal to C2 minus C1 and C3 dash is equal to C3 minus C2. So maximum at a time we are using 2 properties for this determinant to make 2 elements, that is 2 ones as 0, right? So therefore D is equal to within bracket 10 plus A square plus B square plus C square. What is the first column? 1 B square C square. Now column 2 is changing. How does it change? C2 minus C1, 1 minus 1, 0. This minus this, B square cancels, 10. This minus this is also 0. Now C3 dash, that means column 3 is changing. How does it change again here? C3 minus C2, 1 minus 1, 0. This minus this, B square minus B square, 0. C square plus 10 minus C square, that is 10. Is it clear? Now you can expand it. That means you can simplify it now. So let us simplify it now. Now you can expand it with respect to the first row because there are 2 elements 0 in the first row. Now let us expand it now. Therefore D is equal to, write down within bracket, it is 10 plus A square plus B square plus C square, right? So this is the common term here into 1. Now let us expand it with respect to the first row, that is 1 0 0. So what is the method for expanding it? Plus minus plus. Let us take plus 1 first. So write down plus 1. We have already written there 1. If you take this one, if you consider this one, you have to delete the row and the column through the element. That is 1 0 0, that is first row is deleted. Then first column 1 B square C square is deleted. What remains? 10 0 0 10. Now first of all you have to cross multiply 10 by 10. What is 10 by 10? 100. So it is 100. Bisma minus sign answer. This is the second order determinant. 10 0 0 10 is the second order determinant. You know how to expand it, isn't it? 10 tens are 100. Minus, now cross multiply this 0 by this 0. So it is 0. What is 100 minus 0? That is 100. So D is equal to 100 within bracket 10 plus A square plus B square plus C square, right? So in this question actually what was asked, हामीलाई के चाहिएको थियो actually? The given determinant should be the given determinant is divisible by 100. You have to prove it, isn't it? Now this is the simplified expression. This expression shows that since here 100 is common, so this expression is always divisible by 100. That means hence the given determinant is also divisible by 100. So write down this one. This simplified expression is divisible by 100. Is divisible by 100 because here 100 is common out there. That means naturally it is divisible by 100. Okay. So hence the given determinant is also divisible by 100. So you have to write hence the given determinant is also what? Is also divisible by 100. So it is good. So I think you have understood it. You can practice it at home. This is very, very important question. Okay. So now I will give you the homework, right? So copy it. So these are your homework. You can do it at home. So these questions are from 2016, right? Number 1B1, there is evaluate. That means you have to find out the value of this determinant. First row, alpha, beta, gamma, alpha square, beta square, gamma square. This is third row, beta plus gamma, gamma plus alpha, and alpha plus beta. This is the third order determinant. You have to find out the value of this determinant. Okay, you can do it. First of all, R3 dash is equal to R3 plus R1. This will be alpha plus beta plus gamma, this plus this, alpha plus beta plus gamma, this plus this, alpha plus beta plus gamma, this plus this, right? So that alpha plus beta plus gamma is taken outside. This will be 1, 1, 1. You make any two of these three ones 0 by using the property C1 dash is equal to C1 minus C2 or C2 dash is equal to C2 minus C3, like that. Okay? You can use C2 minus C1 or C3 minus C2, like that. Okay? So you have to find out the value of this determinant. Okay? So this is to be number 2, so that this determinant is equal to right hand side. So we can we have done this type of problem. Okay? This is same as problem number. This is same as problem number. Just we did it. That is question number 44. Okay? And this question is same as problem number. This question is same as problem number. Same as this problem is same as 12. Same as problem number 12 of 4 marks section. 12 of 4 marks section, right? 4 marks section. So in the 4 marks section, we did this problem. You can revise it. Okay? So this problem is same as question number 44 that we had just done it. Okay? And this is also same as problem number 12 of 4 marks section. This is same as problem number 12 of 4 marks section. Okay? So you can prove it. And this is similar to this problem. You duita problem say eutai type ko cha. So this is your homework and this is not from your book. Okay? So you prove this LHS is equal to RHS. So this is same as this problem. Is that clear to all of you? So this much is for today. Okay? So thank you.